Okay. Quick question for you. We're at the high school. I'm at the high school right now. Could anybody give me directions on how to get to the middle school? Think you can do it? Some of you maybe. Some of you, and then some of you maybe not, which is fine. I'm not asking you to. Why do I ask for directions for the middle school? That's kind of like a proof. Where did I tell you I'm starting from? Okay, well, I'm going to give you some starting points called givens, like I did yesterday. And then where do I need to end up? At the middle school, right? That's called my proof statement. Okay, I'm going to start you out with some information. You have to end it somewhere, like at the middle school. And then how do I fill in everything in between? That's your knowledge of Delmar to get me to the middle school. Right? That's your knowledge of the street, the Hardane streets of Delmar. Okay? So that's what a proof is. I'm going to give you information. I'm going to ask you to end somewhere that's true, but in the middle is up to you. How do you get to the middle? How do you put it all together? It's like a big, huge puzzle of proof. Can you put the pieces correctly together to get to the end? All right. Unfortunately, though, what you know now just from Unit 1 isn't good enough. So today I'm going to give you 3 other facts that are going to help you connect what I give you to what I need you to prove. The first one, and I'm not going to go over postulates or theorems. I'm not really concerned that you know that. First one that's going to help you in a proof is called the reflexive property. And as you guys read that, I know you're going to be like, is this guy serious? That line segment AB is equal to itself, right? Angle B is equal to itself. You're kind of like, are you kidding me? Where would I ever have to use this? And all I'm going to say is give me to the end of class, and you'll find out why I need reflexive property. All right? So that's the reflexive property. Something is equal to itself. If you turn your attention to the board over here to the right, every time we do a property, it is listed over there. Any property that we do will be given to you on the unit test the day after Columbus Day, remember. Okay, I will give you a whole list of all the facts and theorems we do. You got to know how to use them correctly. Okay, so those will stay up there. All right, next up, the substitution postulate. You guys have done substitution in geometry, in algebra, I believe, right? You've done this, x squared minus 2x plus 3y minus z, x equals negative 4, y equals 15, z equals negative 2. How would you figure out what this value is? What are you going to do with the 4? Everywhere you see an x, substitute it in. What would you do with the 15? Substitute it in everywhere you saw a y. And what would you do with negative 2? Substitute it in everywhere I saw a z, correct? That's what you would do. You can do the same thing for geometry. We could substitute in values. Take a look at my first example here. Using substitution. I'm telling you AB, and I don't need a diagram for this. I don't. AB is equal to twice the length of AD. Everyone good? AB is equal to twice the length of AD. Well, guess what? AD and DB are equal. Can you guys write a true statement right now based off these two and using substitution? Take a look at both. Think about substituting in one for the other and now write a new statement, which is true now. Can you write me a new true statement based off of those two and substituting in something, a quantity, for another one? Okay, here we go. What do we think? Do we have a new one here? 5. Greg, did you get anything? Good job. AB is also twice the length of not only AD, but DB. And if you're wondering where Greg got that, he's like AD equals DB. So anywhere I see AD, I'm going to plug in, substitute in DB. Everyone see the substitution being applied? Any questions? All right, one more, just to make sure we're good. Now I'm going to give you 3 true facts. A and B equal to 90, so they're complementary. A and C are equal. B and D are equal. Can you guys write me at least 2 more correct statements using substitution? So substitute in an angle for another one if they're equal. And write a brand new statement that's going to be true based on substitution. Try to do 2 of them. Try to do 2 of them for me, not just 1 this time. Okay, give me 1 true statement you wrote down using substitution. 16, Nicole, you got one?
Angle C plus angle D is 90.
Yep, angle C. What was the second angle?
D.
D, yep. Angle C plus angle D equals 90. And not only did Nicole do 1 substitution, she actually did 2. Everyone see the 2 that she did? She plugged in C for A and D for B. All right, good. Can you write a new one just using 1 substitution for me? Just substitute in once for me. Give me something new. 15, Tammy. Angle C plus angle B. Good. I believe he substituted in angle C for angle A and rewrote it. And are there more? Yes. Okay, but I just wanted the 2. Sarah, if you need a pass, just fill one out right there. Okay, everyone good with substitution? Okay, I could substitute in something that's equal to another quantity. And substitution right up there as well. Any issues? Because we're going to get to the big one for today right now. Okay, here's where we need to be. Last one, but a big one. Addition. I want you to see this visually first, how this works. So what I'd like you to do off to the side here on your notes is draw me 2 line segments that look equal to each other. Okay, just draw me 2, freehand it, no compass, no straight edge. Just freehand it, 2 line segments that look equal. Call one of them, just put an A on one of them and a B on the other. I don't want to waste time doing endpoints here. So those 2 are equal. Underneath it, can you do another set of segments, a little longer, that are also equal? And call them C and D. How many pairs of congruent segments do we have right now? How many pairs do we have? How many? Go ahead. 2, right? All right. So here's what I want to know from you. Let's say I took segment A and segment C, boom, put them together. All right, I get a longer segment, right? Let's take segment B and segment D, boom, put them together. What do I know about my 2 new segments? Are they? Are they congruent? Okay, great. They are congruent, my 2 new segments. What if I took segment A and segment D? Boom, put them together. And then I did the same thing, segment B and segment C. Boom, put them together. What do you know about the new segments? They are congruent. You guys are doing what's called the addition postulate here. All right, when you add equals to equals, the results are equal. Okay, when you add 2 pairs of equals together, the results are equal. That's addition. So you can see in my statements, I have exactly what we talked about with the segments. So what you guys just told me was A plus, what do you want to add to A? C. A plus C is the same as what? Segment B plus segment D. That's called addition. When you add 2 pairs of equals together, the results are equal. Yep.
Would you also be able to say, like, A times D is...
Oh, this is a multiplication. What's the postulate called? Addition. Done. It's only adding. Okay? We have a subtraction one coming up tomorrow. All right, but this is only adding for now. Or, what else could be true using addition? Are those the only things I could add up and be equal? A plus D is the same length as B plus C. Perfect. Okay? Questions from you guys? All right, you ready? Here it is. Not just a big moment in your geometry careers. I'm talking K through 12 careers right now, math careers. You're about to do your first proof. All right, your first proof. Congratulations. First thing I want to go over is how a proof is set up. All right. First, you guys are used to this from yesterday. I'm going to give you true information. So this is true. I prefer you go right now, mark it on your diagram. Okay, before you wrote anything into statements and reasons, mark it on your diagram. AB congruent to DE, hash marks, right? Because they're segments. How do I mark BC and EF using hash marks? Put two of them now. BC and EF. Good. I will now give you a proof statement. Knowing the givens are true, why is AC the same length as DF? That should be your last statement in the proof. Okay? After you tell me a couple more things, that should be the last statement in your proof is your proof statement every single time. Okay? So now how do I fill in the in-betweens? Using my postulates today. Okay? How do I get from these two being true to AC and DF being equal? Okay? Ready? I'm going to hold your hand on this one. How do I go from AB and BC to AC? How do I go from these two pieces, AB and BC, to AC? What do I need to do? Go ahead, fellas. Go ahead. Don't I have to add them together? Put them together, add them together, right? Everyone agree? AB to BC, I get AC. What do I need to do to DE and EF to get DF? Also add them together. Everyone agrees. So it looks like I'm going to use addition to get AC and DF equal. Everyone agrees? Yes, no, maybe? Okay. If you're going to tell me the word addition, I am always going to respond with, how many pairs of equal quantities did I give you? Two. And that's how many you need to add. If you have two pairs of equal quantities, you are now allowed to add. So our second statement will be, tell me what you're adding together. Okay? You're going to tell me what you're adding together. So what segments am I adding together here? AB plus BC equals, now you're going to tell me what other pairs, because it's going to be equal to the other pairs added together, which are DE plus EF. This is addition right here. Does that make sense what we wrote there? These two added equal to these two because the pairs were equal. Reason why they're equal? What's the postulate? Addition. And I don't need to have the word postulate, by the way. Addition will be just fine. Is that my proof statement, though? No, they don't match. So I got to keep going now. Got to keep going because that's got to be my last statement. All right, so we got to add in more before we get there. Ready? AB plus BC. Give me another name for it. AB plus BC. What's another name? So can I just, instead of AB plus BC, plug in AC? It's the same thing. It means the same thing. Equal to, what's the same thing as DE plus EF? Oh, so I can replace it with DF. Plug it in for, replace. What allowed me to write this? Darn right, substitution. You see how I got there? Oh, they're equal, so I can add them by addition, and then I could substitute in AC because that's the same as AB plus BC. Is that my proof statement, what I asked you to prove true? Is that what I asked you to prove true, statement 3? Okay, so we're good. Questions, comments, concerns? Anything? One doesn't make you, congratulations. One doesn't make you great, though. Okay, one doesn't make you great. Let's see if you can do it with angles now and not segments. Notice I did not write in the givens for you like I did on the last proof. That's the first thing you want to do. Write them in and mark them on your diagram, all right? Write them in, mark it on your diagram. ADF equals CBE. EDC equals ABF. And I know it's going to be a little elementary schoolish of me, but I am going to walk around and watch you mark those two angles, or those pairs of angles congruent. So you should be putting arc marks on the diagram where those two angles are. Follow it with your finger, your pen, pencil. Figure out where those angles are. And mark them with arc marks. One pair for one angle, two arc marks for the other pair. There's everybody. Follow it with your pencil, pen. The middle letter tells you where it goes. Hold on with this one. A, ready? A to D to F. See that angle for me? Get that. And then it's C, B, E. C to B to E. Good deal, good deal. Mark your other pair, Matt. Go ahead, mark your other pair. Good job. Okay, nothing in the middle though. What did you think was those? We wouldn't be connected lines because it's just going to be confusing again. All right, do your ones here. So A, D, A, where's D? D, F, you see the angle for me? Right there, right? And then C, B, E. C to B, where's E? See that angle for me? C, B, E, where is it? C to B to E. The middle letter always helps you out. See it? Right here. C to B to E. Okay? We're going to mark those congruent. Okay, most of you guys have these marked congruent. I'll do the same on mine right now. Let's see here. ADF right here, congruent to CBE. So we should all of us should have those two. Check them, please. Check them. Along with EDC and ABF. Those two. We all good? Okay. Let's now look at the angles we need to prove congruent now. Show me that ADC. Find it. AD to C. Find that angle. ADC right there for me. I'm just highlighting it for you guys so we're both on the same page. Congruent to ABC. That one right there. We're all good? Okay, so here's my question. How do I get to these given angles to the full angle? What do I need to do to the given angles I was provided to get to the bigger ones? The smaller ones to the bigger ones. What do I need to do with them? Add them together. Everyone see this is addition now, but now with angles. Do you see if I put those two bottom left ones together, I get the full one? We're all good? Okay, you said adding. How many pairs of equal quantities do you need to add? Two pair, right? How many did I provide? How many pairs did I provide that were equal? Two. So those are the two you can add together. You just got to tell me which ones you're adding together. Okay, give me a pair to add together. That's going to create one of the bigger angles. 1/8, go ahead. Claire. Angle. A, hold on. A, B, okay, got you. Angle ABF plus. Oh, ADF, excuse me. Sorry. ADF plus. EDC, perfect, thank you, is going to be equal to, what's the other pair I'm going to add together to get the other bigger angle? Twos? Quan?
Angle CBE.
CBE, good, plus?
Angle
ABF. And what allowed me to do that? Addition. I can do it for angles or segments. If I know two pair are equal, I can add them together. Is that my proof statement? Nope, got to go at least another step, maybe more. Go ahead, take ADF, combine it, add it to EDC. What angle is formed? ADC. So I'm going to replace it, substitute it in for that first statement. Equals, what about the second part? CBE plus angle ABF. ABC. And what did I use to plug it in? Replace it? Substitution. So that's using angles versus segments. Questions from you guys? All right, I don't want you to think it's always given, addition, substitution, because that's not going to be the case. And that's why we are going to end class on number 3 right now. Okay? Let's write it in. Let's mark our diagram. DE is equal to BF. Given. Mark it on your diagram with your hash marks. DE congruent to BF. Okay. All good? Write it down, given, mark it. Look at the proof statement now. How can I get line segment DF to be the same as BE? Okay. Why would DF be the same length as BE now? Oh boy. Oh boy. We'll start with what you're given. DE and BF. Ready? If I start at DE, how do I get to DF? What do I need to do? Add what? EF, okay. Everyone agrees? I can add EF to it and get DF. I like it. Let me go over to the other side. BF. I got BF in the givens. How do I get to BE? I have to add what? EF. Everyone agrees with that statement? I got to add EF. But you guys keep saying adding, but don't I need 2 pairs to add? How many did I give you? How many are in the given right now? 1 or 2 pairs of equals? 1. So you can't add right now. You don't have another pair to add to it, do you? But what did you just tell me? To DE and BF, what do you need to add to both of them? EF, right? I got to add EF to DE, and I got to add EF to BF. Guys, what do you know about EF and EF?
They're the same.
Aren't they equal? Something equal to itself? Everyone see it? Oh, you want me to add EF to both? No problem, because I already know EF is congruent or equal to itself based on what property? There you go. That's where it's going to be used. Do you guys see? I cannot add in step number 2. Do you understand why I cannot add? I don't have anything to add to DE and BF until I write it's equal to each other. Okay, I cannot add in step 2. Now can I? Have I written everything where I can now add them? Yeah, you got 2 pairs. Add them together.
Do you have to mark that though?
You could. We haven't gotten to this point, but anything that's reflexive, I never mark with hash marks. I always mark with an X, but that's just how I roll. Serena, you can mark it with a happy face for all I care. Okay, I just roll with an X. Now that you've listed that both pairs are equal, now you can add them together. But they have to be equal to each other for you to add. DE plus EF equals BF plus EF. Are you seeing that before you add, you need to tell me the 2 pairs are equal somewhere, whether I give it to you or you write the reflexive in? Addition. Now, how do I finish this? Substitution. If you don't have another pair to add, I guarantee it's going to come from something being equal to itself. Okay, so please watch out. If you know you have to add on tonight's homework and you only have one pair of equals in the givens, the other pair, it's going to be something equal to itself before you add. Go to the homework, speaking of the homework, because I got to warn you about a couple things. Because I cannot have you guys get frustrated on me and give up. Because remember, there's no answer key. Numbers 1 through 4, you're just telling me what postulate we're using. All right, it's not a proof. Don't do statements and reasons. 1 through 4, what property / postulate am I doing? Starting at number 5 all the way to 10, that is when you do a statements reasons for me tonight. Please focus in right now on me. I'm going to tell you right now, not all of them go given, addition, substitution. I can tell you numbers 5 and 6 have nothing to do with addition. Okay? It might not even be 3 steps. It might just be 2. Okay? Remember, hey, these are the 3 you can use tonight. You may just use substitution and that's it. And you're done with the proof. All right? Don't think you have to use substitution and addition every time. It may not be an addition proof. It may just be substitution. Hint, 5 and 6. Okay? It might just be substitution. All right? Adding is when you put 2 pairs together to get a whole pair. So we'll see what you can do with it tonight. All right? We'll see what you can do with it tonight. We still have 5 minutes, and I wanted to make sure that you had an opportunity to complete the notes before I did this.